Hello, my dear students. Hope you are doing well. Today I'm going to continue the explanation of Chapter 10, Aldehydes and Ketones. The topic is chemical reactions. The objectives that I hope you will understand at the end of the session are two. The first one is to identify the common properties of aldehydes and ketones. The second one is to recognize the distinctive properties between aldehydes and ketones. Let's begin with the first objective, to identify the common properties of aldehydes and ketones. Now, do you remember what is the functional group of aldehydes and ketones? Both aldehydes and ketones contain carbonyl group C double bond O. This group consists of a double covalent bond, therefore they undergo same reactions like addition reactions, oxidation, reduction, etc. Let's see here the common chemical properties of aldehydes and ketones. The first one is catalytic hydrogenation. The second one is test with sodium hydrogen sulfide. The third one is test with DNPH. Let's explain each one alone. Start with catalytic hydrogenation. It consists of adding a hydrogen molecule to the carbonyl group to produce an alcohol in presence of metallic catalysts such as nickel or platinum or palladium. The condensed general molecular formula of aldehyde is CrCHO plus H2. What do we get? We get primary alcohol of condensed general molecular formula of RCH2OH. In reality, what happens here? Let's take an example. Ethanol CH3 C double bond OH, add to it H2 in presence of hot nickel. The double bond is going to break down and we'll have one hydrogen atom is bonded to carbon of the carbonyl group and the second hydrogen is bonded to the O, and what do you get here? CH3 bond CH2 OH. The OH is the functional group of alcohol. So here we have the ethanol is changed to ethanol. Let's take the ketone. Catalytic hydrogenation of ketone. The condensed general molecular formula of ketone is RCOR'. Add to it hydrogen molecule. What do we get? We get secondary alcohol. Example here, we'll start with propanone. Propanone that consists of 3 carbon atoms. Add to it hydrogen in the presence of hot nickel, and the hydrogen atom, one hydrogen atom is bonded to the carbon of the carbonyl group and the other hydrogen is bonded to the O, and we get here OH. The product will be 2-propanol. Now let's try to remember together what happens in alcohol. We have the dehydrogenation of alcohol. In catalytic dehydrogenation of alcohol, we have primary alcohol. By removing H2, you will get aldehyde, and the secondary alcohol by dehydrogenation. It means removing of the H2, we get ketone. So these two reactions are reversible reactions: catalytic hydrogenation and catalytic dehydrogenation, but they are not chemical equilibrium reactions because they take place in different experimental conditions. Let's remember the catalytic dehydrogenation of primary alcohol. We use the catalyst copper and the temperature 300 degree, while here catalytic hydrogenation of aldehydes and ketones, we use nickel, and the temperature is different from the dehydrogenation of alcohol. Now the second common property is using test with sodium hydrogen sulfide. The objective is to identify carbonyl group in a compound. What is the procedure? The procedure is, in a test tube, place 3 milliliter of sodium hydrogen sulfide freshly prepared. Add 1 milliliter of an organic compound. If a white precipitate appears, it means positive test. The compound tested contains a carbonyl group. It is either aldehyde or ketone. If no white precipitate, it means negative test. The compound tested doesn't contain a carbonyl group. Now the third test is with DNPH. Here, what do we mean by DNPH? It is a molecule that consists has the name dinitrophenylhydrazine. You are not responsible for drawing the structural formula, and you are not responsible for the reactions. Only you have to know the experiment and the test. Identify here a carbonyl group in a compound. The procedure in a test tube, place 3 milliliter of DNPH. Add 1 milliliter of an organic compound. If a yellow-orange precipitate appears, it means positive test. The compound tested contains a carbonyl group. It is either aldehyde or ketone. If no yellow-orange precipitate, it means it is negative test. As you see in the first figure, no precipitate. The compound tested doesn't contain a carbonyl group. So as you see here, we have three reactions. The first one, let's remember them together. The first one is catalytic hydrogenation. The second to test with sodium hydrogen sulfide, and the third to test with DNPH. Now let's move to the second objective. Recognize the distinctive properties between aldehydes and ketones. Now, what is the distinctive chemical properties? Here, these properties are due to the presence of hydrogen atom in the functional groups of aldehydes and its absence from that of ketones. Thus, aldehydes are reductant compounds that react with oxidant solutions while ketones don't. So aldehydes, the carbonyl group here is bonded to the hydrogen, while in ketones the carbonyl group is not bonded to hydrogen. So aldehydes are reductant compounds, while ketones are not reductant compounds. To recognize the distinctive properties between aldehydes and ketones, there are several tests or several reactions. Let's see them. Chemical reactions specific to aldehydes only. What are these chemical reactions? Let's see. Mild oxidation with oxygen gas. The second one is mild oxidation with oxidizing solution in acidic medium. The third one, test with Tollens reagent. The fourth one, test with Fehling's reagent. And the last one, test with Schiff's reagent. So let's start with the first one, which is mild oxidation with oxygen gas. Let's remember here the alcohol. In mild oxidation with oxygen gas, the alcohol has a test which is called flameless lamp test. This test, we have here a volumetric flask. We introduce in it 20 milliliter of ethanol. We connect the apparatus to an aspirator, heat the ethanol to lukewarm in a hot water bath, heated over the hot plate. Heat the copper wire to red hot and quickly introduce it in the volumetric flask. Observe what happens. In a case of ethanol, you will have the reaction will be ethanol plus half O2 will get ethanol. This is, we get it in chapter of alcohol. Now, upon continuous mild oxidation, the aldehyde, which is the ethanol plus half O2 in the presence of this copper wire, what do we get? We get the ethanoic acid. So ethanol can change to ethanoic acid. Now, how can we test the presence or the formation of ethanoic acid? Let's take a sample from the solution and put it in a beaker. Introduce litmus paper, blue one. If it turns red, it means the formation of acid, which is ethanoic acid. If you have, let's say, ketone, the ketone plus half O2, we say here, which is a propanone, use the test sample from this one and use the litmus paper, the blue litmus paper, it becomes blue. So no reaction takes place here because the ketone does not undergo continuous mild oxidation. Now let's move to the second test, which is mild oxidation with oxidizing solution in acidic medium. It is orange dichromate solution. Here the reduction half reaction. Let's remember together how do we write it. The dichromate becomes a Cr3+, first step, we balance the CR by multiplying CR3 plus with 2. Second, we balance the oxygen by adding water, 7H2O. The third step, we balance the hydrogen by adding H+. The fourth step, balancing the charges by adding 6 electrons. Now the oxidation half reaction, the aldehyde, it becomes carboxylic acid. The first step, we balance the carbon atoms. They are balanced because it is mild oxidation, the same number of carbon atoms. Second step, we balance the oxygen by adding water on the reactant side. And the third step, balance hydrogen by adding 2H plus on the product side. And the last step, to balance charges by adding 2 electrons on the product side. Now we want to add these two equations to get the overall equation, but here the number of electrons gained and lost should be equal, so we multiply the oxidation half reaction by 3 and you will get the 6 electrons in the reduction half reaction and 6 electrons on the in the oxidation half reaction. The overall reaction will be 3RCHO plus Cr2O7 2 minus plus 8H plus to get the product 3 carboxylic acid plus 2 Cr3 plus 4H2O. Here the orange color of the dichromate becomes green because of the formation of the Cr3 plus. Now the third test is called Tollens reagent. Now the Tollens reagent, we have the objective here: distinguish experimentally an aldehyde from ketone. We identify in this case an aldehyde. The procedure is: in a test tube, place 3 milliliters of toluene reagent, a basic ammoniacal silver nitrate solution. Here the solution is basic. Add 1 milliliter of a carbonyl compound, aldehydes or ketones. Put the tube in a water bath between temperature 50 to 60 degrees Celsius. The observation will be here: if a silver mirror color appears on the walls of the test tube, it means in the test tube we have aldehyde, which is positive test. The test tube that that remains colorless, يعني if the solution remains colorless, it means the reactant is ketone because it gives negative test. Now let's move to the fourth test to distinguish aldehyde from ketone. It is Fehling's test. The objective here is use Fehling's test to distinguish experimentally an aldehyde from a ketone, so to identify an aldehyde. The procedure is the same procedure. In a test tube, place 3 milliliter, but here Fehling's reagent. The medium is basic, or a basic blue solution of copper 2 complex tartarate ions. We use here, you add 1 milliliter of a carbonyl compound, aldehyde or ketone. The observation gently heat in the flame of Bunsen burner, and the observation will be: if a brick red precipitate appears in the test tube, it means the reactant is aldehyde. it is a positive test. If the solution remains blue, it means it is ketone and you get negative test. So if the solution remains blue, it means it is ketone. If it changes to brick red precipitate, it means it is aldehyde. So here you have to memorize the colors, and don't forget these colors. The equations, as you see, you're not responsible of writing the equations. Okay, now let's move to the last test, which is Chiv's test. The objective, similarly, we have to distinguish experimentally an aldehyde from a ketone in order to identify an aldehyde. The procedure: in a test tube, place 3 ml Chiv's reagent. Cool the content of the tube in an ice water bath. Add 2 drops of a carbonyl compound, aldehyde or ketone. The observation will be: if a purple-pink color appears in the test tube, it means it is aldehyde. We say it is positive test. If the solution remains colorless, it means it is ketone, negative test. So you have to recognize here the colors. Again, if it is purple pink color, it means presence of aldehyde. If the solution remains colorless, it means the reactant is ketone. So these are the tests to distinguish aldehydes from ketones. So try to memorize the colors in these tests and don't forget them. At the end, I hope that you like this session and you are interested in it. Hope to see you next time. Thank you.